Understanding function notation. In order to understand functions, we must first understand the terminology, beginning with input and output. A function is simply a relation between two sets of numbers. One set is called the input, which is what you put into the function, and the other set is called the output, which is what you get out. The input is often referred to as your x value. Your output is the same as your y value, which is sometimes called f of x. What is f of x? F of x is just another way of writing y, which is an output. When you plug in some input, x, you will find the output, f of x, for that given number. For example, find f of 3 for the function f of x equals 5x minus 7. First, you plug in your x, which is now 3. Then, you use your order of operations to solve. 3 times 5 is 15. Then 15 minus 7 is 8. Therefore, f of 3 is 8. Domain and range. The domain of a function is the set of all possible inputs. In other words, what numbers could x potentially be? The range is the set of all possible outputs. In other words, what numbers could y or f of x potentially be? In this table, we are only given 4 points. Therefore, we only know of 4 possible x values, which are 6, 7, 8, and 9. This is the domain of the function. For the range, however, there are only 2 different f of x values. Therefore, range is just 13 and 16. Function limitations. In order to qualify as a function, each element in the domain can only be assigned to one element in the range. In other words, a function cannot have 2 points with the same input but different outputs. In the following example, the input of 2 shows up multiple times with a different output in each case. This is not allowed. Therefore, the following table cannot be a function. Let's practice. Which function has the following domain? The domain given is a set of 3 numbers, -4, 3, and 5. Remember that domain deals with possible x values, so our graph should have points when x is -4, 3, and 5. The answer is not B because a line is just an infinite series of points right next to each other, meaning that it has x values at 0, 1, 2, 3, etc., and everywhere in between. The answer is not C because it has a point at x equals 0 on the y-axis. Therefore, A is our answer because it only has points where the x value is either -4, 3, or 5. Here is another practice problem. Which of the following sets of ordered pairs cannot be a function? We must remember that a function cannot have repeated x values with different y values. The only answer that repeats x values is C, and since the y values are different, it is not a function. Let's do one last practice problem. In which of the following functions does f of 3 equal 24? F of 3 means that we are substituting in 3 for x, and the output we should get is 24. Let's try A. After plugging in 3, you end up with 3 minus 2 in the parentheses, which is 1. So 3 times 1 is just 3, so f of 3 equals 3. Since it does not equal 24, this is not the function we are looking for. Let's try B. After plugging in 3, you end up with 3 minus 3 in parentheses, which is 0. 3 times 0 is also 0, so our answer is just 3. Therefore, f of 3 equals 3. Still not 24, so the answer must be C. Let's work it out just in case. After plugging in 3, you get 3 plus 9 in parentheses, which is 12. Then 2 times 12 is 24, so f of 3 equals 24. That is the correct answer.